All right. Hello and welcome to THR111 lighting section. Today we're going to talk about power circuiting and some basic paperwork type of things. And then also there's going to be a reading a light plot video that'll be separate from this. But for the sake of your sanity and mine, hopefully I'm going to make these shorter than my last video, just to keep it more brief. So cool. So let's get started. See if I can get, what am I doing? Okay, there it is. All right. So these are some great videos. I won't play them because I'll let you play them on your own. They're attached to the PowerPoint that is up on D2L. Feel free to watch these at your leisure. They're pretty cool. They're just videos about backstage life during some major musical productions. Kind of gives you a little more insight as to what electricians and lighting people do in general. So cool. So so I'm first going to start talking about how the lights get their power and why. So I'm going to just do some basic electricity kind of stuff just to kind of give you an overview. But I think the overall idea that I want to get instilled into your brain about how we use electricity in the world of lighting is the word resistance. Now, resistance is what causes the brightness of a bulb, or is what causes light to happen in a light bulb. And really, in lighting, we're just kind of controlling this resistance of electrical current in order to make light. So really, when it comes down to it, what we're doing is just controlling resistance, allowing electricity to flow and stopping it. So, but these are just some basic principles I kind of wanted to go over, just to kind of give you a basic idea of what we're working with. So watts, work being done in an electrical system to overcome resistance. So watts you will see referred to as, if you go to a store and buy a light bulb, you'll see that a light bulb is rated in a certain amount of watts, right? Because sometimes you'll have to buy a light bulb and the amount of watts has to fit whatever lighting fixture you're using, right? So that's the work being done. That's the amount of work that is being sent through, let's say, your wall outlet to your light, right? So your light bulb can only handle, 60 watts or 50 watts, right? It can only handle this much. So that's how much work is being done to this light bulb in order to make it work, right? The amount of resistance happening in the filament of a bulb to make it work. So it's just really, these are all just really ways of measuring electricity, right? And the next one is ohms. And this is a term that you should know, but you won't see as often as you will some other places. So ohms is resistance within an electrical current. So it kind of takes in everything to kind of give you an overall idea of how much resistance is happening in an entire electrical system. And then the two underneath that are more common terms you've probably seen. So volts is the potential energy within an electrical system. So things are rated in volts. Batteries, right? There's a 9-volt. So that's the potential energy that this battery can give off. Now, whatever you're using might not take the whole 9 volts, but knowing that your battery can take all 9 volts is kind of the idea here, right? And your typical wall outlet is 120 volts. So, whatever you plug into your wall won't use all 120 volts, but that's the potential of how much it can use, right? So if you plug in your phone, it might only use like 15 or 12 volts, right? But having that potential of using all 120 volts is really that measurement. And then underneath that is our amps, right? This is the measure of the electrical flow or current in an electrical conductor. So cables are measured in amps, right? This is just measuring how fast something can travel. And I have a little, so, right, so this is kind of, this is a cool little animation or graphic that I found to kind of explain pretty well how it works. So your ohm, right, he's the one kind of controlling, think of the ohm as, so we rate cables in ohms, right? So think about this ohm guy. He's pulling this cable, tightening the amps because he's acting kind of as this cable resistor. And then we have our volts, which is, if you think about our wall outlet, trying to push all this potential energy through our ohms, which is our cable, and whatever is being pushed through that is our amps, right? So, but again, you don't need to memorize all of this. Just know that this is we're all just working with resistance in order to make this potential energy that we need, right? And then, again, I was talking about this. So the resistance along the wire, right? That's your ohms and your amps. And then the resistance in the light bulb, right? So we have our electricity going through this filament, which is heating up, causing all of this lights. And it also causes a lot of heat, right? So, and the light bulb is also a resistor. So all of these are really just resisting electricity, which is causing this heat and which is causing things to light up, right? So in the lighting world, we're really just controlling how much resistance is going through a system at its most basic understanding, if that makes sense. So to get more now into practical things, circuiting. So the act of circuiting is really just a fancy way of what we call plugging things in, right? So every light has to get plugged into somewhere, and we just refer to all of that as circuiting. So if you kind of hear that, just know it's really just a fancy way of saying how I'm plugging something in, right? So these are just some terms to kind of go along with circuiting. So cable, right? I'm sure we all know what a cable is. A cord which contains multiple wires, typically 3. Cables are categorized by numbers of wires, types of jacking capacity, right? There's tons of different cables. But in a lighting sense, our cables really have 3 little wires inside of them, right, to carry different kind of electrical currents. A connector, the termination of a cable, which allows for ease of plugging and unplugging, right? So every cable has a connector, and whether that's your typical 3-prong household, or in the lighting sense, we use 3-pin, which I'll get into in a minute. But they all take different connectors, but they're all trying to kind of do the same thing. So racetrack, that's pretty common way that we help plug things in. You can kind of see that over here in this picture with all these white lights. They're we call our racetrack, which is just a way of hanging a bunch of lights. You'll see those in a lot of architecture. We don't use them as theater as much, but they are pretty common to see around. Multi-cable, a large cable or connector which allows multiple circuits to plug into a single line, commonly called a socket PEX. So this is this big one right here. So we're taking a lot of, we'll usually plug this into somewhere in the building that has a lot of a large amount of electricity that we can use, and then we kind of branch that out to these little cables. It's just kind of an easier way to spread the love evenly, if that makes sense. And then lastly, I'll kind of talk about this more when we talk about plots. An electric is like a racetrack, but it's usually just a really long bar, which we call a batten. It's a long pipe that we hang lights on, lives in a theater. But a type of batten, and I'm sure in a scenic section, you've talked about certain battens and stuff like that. And in the lighting world, we call our battens that hold all of our lighting instruments, we call them electrics. So if you hear me refer to something as an electric, it's referring to the batten where we're hanging lights on. So types of connectors. So these are the 3 you'll see in theater the most, right? So we have our Edison, our most common, used in residential buildings. We still use those in theater for if there's a lamp on stage or something like that. But beneath that is our most common you'll see in theater, which is we call a 3-pin or a stage pin. And we use them because they're so bulky, and when you're up at the catwalks working, it's pretty easy to drop cables and stuff like that. So we use pretty beefy connectors in order to not bust them constantly. Edison connectors are really useful in household use, but we're chucking these cables everywhere and abusing them. So we need a little chunkier connector, and that's why we use the stage pin. And then the twist lock, those are used for a lot higher power equipment, like our moving fixtures. You'll see them typically used for like welders and bigger power tools and stuff like that. But it's kind of the same way in lighting. We use it for instruments that need a lot more power. And the reason is because we need the twist lock to kind of make sure that doesn't come unplugged, because it can be an electrical hazard if it comes unplugged easily. So you remember me talking about wiring. So there's 3 wires within a cable. We have our ground and our neutral are hot, right? And you'll kind of see this similar, and I won't really get into this too much, but you see this similar in like a car, right? You got your negative, your positive, and then your ground. And the only really thing you need to know about this is being able to measure the gauge of a wire, being able to tell how much ohms this wire can take, how much power can actually go through it. Now, of course, a thinner wire will only take so much, and a bigger will take a lot more. So being able to kind of measure that gauge is important. Um, so this is a useful little tool we use in the lighting world because sometimes we have more lights than we do outlets. So we have to share lights in outlets, and to kind of make sure that that's safe to do without kind of, blowing everything up, we have to make sure that we can, the amount of lights can take what they need, right? So we'll use this, the volts times amps equals the watts relationship in order to, we call the West Virginia law. We kind of use this in order to make sure that we can plug 2 lights into a certain socket, right? Because some lights will take more wattage than another, so we need to know that our system that we're using can actually handle it. And then an important thing I want to make sure that you understand is that the typical outlet in your house will take 120 volts, and then a lot of theaters will use 208 volts just so we can have more power. But knowing that is pretty important. Cool. So last, I'm going to talk a little bit about paperwork, and this will lead me into light plot stuff. So you've heard me refer to a light plot. A light plot is a visual representation or map of a pertinent information needed for a given production, including instruments, positions, focus, color, channel, etc. Think of it as just a blueprint of where our lights are going. And if you saw drawings of scenic designs, it's kind of the same way. It's a map that we use as electricians to make sure that all of our lights are hung the right place, they're plugged in the right place, and that they have the right color, everything like that. But I'll get into that in the next video. So instrument schedule. So these are the other paperwork that mostly is used between the lighting designer and the electricians, the master electrician, to kind of communicate to make sure that everything's getting done what it should. So an instrument schedule is a list of instruments, pertinent information for a given production organized by position, right? This is, I would say, mostly used for inventory sakes to make sure that if a lighting designer designs that they actually have all of those lights in stock in order to actually perform this design. So making sure that all the instruments are there that we need. Channel hookup, so a list of instruments and pertinent information for production organized by channel number. So this is more for the master electrician and the lighting designer as well, because they use their channel hookup to communicate with the board or the control, whatever control they're using, to the actual lights. So this is just a long list of assigning lights to a certain channel in order to have the board talk to that certain light. And then our cue sheet, our list of detailed information, pertinent information for given cue, organized by cue number. So this is given to the stage manager so that they can make sure that everything in their script is where it should be, all the right light cues are in the right place, right? It's just a form of communication between the lighting designer and stage manager. And then a magic sheet is a graphical display of the lighting systems and specials used in a given production. Now, a magic sheet is, I won't show you one because there really, it depends on what kind of designer you are. You learn about magic sheets if you take, I think, Lighting 211. Magic sheets are used in the design process to just make the actual design process fast. So if you're in the space designing lights and bringing lights up, the magic sheet is just kind of a shortcut for the designer to kind of look at and be like, oh, bring this light up this here. And magic sheets can look like anything you really want. Typically, they look like the lighting plot, and they just have little shortcuts in them to kind of for the lighting designer to bring up something quickly. But it really depends on the designer. These are just some, and then next I have some just examples of different types of paperwork, right? So this is an instrument schedule. So it's really all of the information that someone like the electricians will need to make sure that they have all the right equipment. So the position, this would be where it is physically on the plot, right? So first beam is just a location, right? Instrument type, instrument number, I'll get into that when I talk about lighting plots. But it has just all of the instrument. The purpose of it, the purpose is for the lighting designer being like, oh, this specific light is for, I don't know, lighting this person here, or just front fill light, or so right, chandelier front light, stuff like that. But it's all laid out here. And then similarly is the channel hookup. This is more for purpose of lights, right? So we have our channel number, where it's plugged into the light, where it's focused to, right? And then if it has a purpose or if it has a certain color in it or a gobo, kind of all that information. And then lastly, we have our cue sheet. So um, this one, right, has our cue number, our page number of our script, what the cue actually does, right, the intent, and then the notes is for usually for the stage manager, right, has maybe a line where they want that cue to happen, or just kind of right. So with the school bell sound cue, right. So it's to communicate with the stage manager where everything goes and when. Cool. So um, I'm going to stop this video and tune into the reading a plot video for the next one. Thanks.